We go with quadratics. We're going to look at factoring. Factoring out GCF, you're just taking what's common in all terms provided. So if we look at this first example, what number can come in? What number goes into 15 and 3? 3. So we can take a 3 out, and we're left with a 5, and 3 divided by 3 is just 1. So you're just left with that. Now looking at the variables, I have 4 x's in the first term, 5 in the second. So how many total x's can I take out of both? 4. And if I do that, 4 minus 4 is 0, so there's nothing here. And then I have 5 x's, I took away 4. How many are left? 1. So my factor, my greatest common factor is 3x to the 4th, and what's left? 5 plus x. So quick recap, and you can always go back and check your work. Let's do that first. And I'll show you why this works. 3 times 5 is 15. Remember, and then I just have my x to the 4th. 3 times 1 is 3. I have 4 x's. I add 1, so I have x to the 5th, which is exactly what I had up top. So this is why this works. Remember, exponents, you add and subtract them. We go on to number 2. What greatest common number is in both 16 and 24? It's 8. Another way you could do this is by breaking it down. 4 times 4 gives me 16. 4 times 6 gives me 24. Break it down, you're just doing factor trees. 2 times 2 gives me 4. 2 times 3 gives me 6. What is in both? I have a 2, another 2, another 2, and then that's it. So 2 times 2 times 2 is 8, giving me 8 as my GCF. And there's no variables in anything else, so I can just factor this out. 16 divided by 8 is 2. X squared plus 24 divided by 8 is 3. Okay, let's look at number 4. What's in both terms that can be factored out? Well, this one's easy. They've already factored it out. X minus 3 can come out. And what are we left with? 3x plus 2. So we see a 3x and a positive 2. That makes up my final factor. All right, look at number 3. What number can go into 18, 36, and 42? And that's 6. 6 can go into all of these. That's the highest one. And if it helps, write out all your variables. So I have 18. I have 4 x's, 7 y's. I have 3 x's and 6 y's. And then I have 5 x's and 5 y's. So we said what number can come out of all of these? 6. 18 divided by 6 is 3. 36 divided by 3 is 6. And 42 divided by 3 is 7. And how many x's can come out of everything? 3. So I can take out 3 x's. So x cubed. How many y's can we take out? I have a total, max is 5, so I can take out 5 y's. Then you write what's left. 18 divided by 6 is 3. We have 1 x and 2 y's. 36 divided by 6 is 6. We have no x's left, so we don't write that down, and we have 1 y left. 42 divided by 6 is negative 7, and we had 2 x's left. And that's it in factored form. Now, is it going to get this complicated on the ACT? I don't know. Probably wouldn't think so, but it could, so make sure you guys know how to do it. You can either break it down or you could just look at the exponents. Either way, whatever works best for you. Okay, quick recap of multiplying. We did this a few days ago, the very first day of this unit. You're going to distribute this x to everything in the parentheses behind it. So x times x is x squared, and which is what we have. X times 3 is 3x. And then we do the same thing with this 6. 6 times x is 6x. 6 times 3 is 18. When we combine like terms, 3x plus 6x gives us 9x. And our last number is 18. So this is the product of 6 and 3. And 9 is the addition of 6 and 3. So we're going to use that when we factor, which is what we're getting into now. So this is recap of freshman year and first semester factoring. I take my variable, I'm going to split it up. I know x times x gives me x squared. Easy peasy. Now think of what are the factors of 18 that multiply to give you 18 and add to give you 9. And it's 6 and 3. 6 times 3 is 18. 6 plus 3 is 9. So this is this expression in factored form. On to B. I have x squared, so it's going to start with x in both parentheses. If I have a subtraction sign, that means I want to subtract to get this number. So what are the factors of 40? What multiplies to give me negative 40 and subtracts to give me a positive 6? So you can kind of play around with this and think about what are those values. I could do 10 and 4. Do 10 times 4 give me 40 and 10 minus 4 give me 6? Yes. In order for 6 to be positive, 10 has to be positive and 4 is negative. 10 times negative 4 is negative 40. 10 minus 4 is 6. On to C. I have x squared. And if it helps, list out all your factors of this last number. 14 is 1 and 14, 2 and 7. And then I could have whatever numbers with the negatives and positives. So which two numbers can multiply to give me 14 and add or subtract to give me 5? 2 and 7. In order for 5 to be positive, which value has to be positive? 7, and the 2 needs to be negative. Negative 2 times 7 is negative 14. Negative 2 plus 7 is negative 5. All right. What do I do if I don't have just x squared? I have another number in front. Well, don't worry, Julius. I've got an answer for you. First thing is look and see if that number can be taken out of everything. So if we look at I, 2 goes into all of these terms. So we're going to factor out this 2 like we would have up at the top. So when we take out 2, we're left with g squared. 14 divided by 2 is 7. 24 divided by 2 is 12. Now I can factor it out just like we did up here. So I'm going to leave this 2 on the outside. And now we're going to factor it out. So we have g and g. What are the factors of 12 that add to give me negative 7? So 1 and 12, 3 and 4, 2 and 6. 3 and 4 are the only ones that can give me 7. And I need them to add to give me a negative 7, so they're both negative. Negative 3 times negative 4 is positive 12. Negative 3 plus negative 4 is negative 7. And then that means this entire thing is your answer. You cannot forget about that 2. So make sure you leave that 2 out there. You're going to do the same thing with all of that. All right, let's look at some other types of factoring. Okay, you have a difference of 2 squares. These are my favorite. These are the easiest. All you do, they're perfect squares. So x times x gives me x squared. 6 times 6 gives me 36. I make one positive, one negative. That way the middle cancels out, and I'll show you why that works. We distribute x times x is x squared. X times negative 6 is negative 6x. 6 times x is positive 6x. Positive 6 times negative 6 is negative 36. When we look, what happens here is those cancel out. So all we're left with is x squared minus 36, which was our original thing. So in order to not have a middle term, one has to be positive, one has to be negative. And these are just easier that way. We look at b. Square root of m squared is m. Square root of 9 is 3. But I don't have a difference of perfect squares. Positive 3 times positive 3 gives me 9, and then I'm going to have my middle thing. So this does not work. This is a sum of squares. So it's not going to factor out nicely. We look at c, square root of m to the 4th. This is going to be m squared. Because m squared times m squared gives me m to the 4th. Square root of 81 is 9. I make one positive and one negative. Square root of 4 is 2. Square root of b squared is b. Square root of 400 is 20. Make one positive, one negative. You also could have factored out the 4 first. We could have taken this 4 out, and we're left with b squared minus 100. And then square root of b squared is b. Square root of 100 is 10. Make one positive, one negative. And you're going to get the same answer either way. Because if we factor out all these 2's, you're going to get the 4 out in front. So either way is correct. Okay, perfect square trinomials work the same way. However, you're not eliminating the middle part, so the signs are going to be the same. So what's the square root of 4? 2. Square root of x squared is x. Square root of 9 is 3, and they're both going to be positive, so whatever this sign is. You can always check your work. It's also written 2x plus 3 squared, same thing. You can always check your work and make sure you did it right. So we have 2x times 2x is 4x squared. 2x times 3 is 6x. 3 times 2x is 6x. 3 times 3 is 9. 6 plus 6 is 12. That's your answer. Let's do one more. Square root of 64 is 8. Square root of a squared is a. Square root of 9 is 3. And they're both going to be negative. You always go back and check your work. But this is how you do perfect square trinomials. Please, please, please make sure you do the practice on Go Formative. That's the only way you can get better.